A very good morning to everyone. Today I am Master Prithvish. I am going to speak upon the topic Hill Hold Assist and Adaptive Cruise Control Systems. So the primary question we all ask is, why do we need hill hold control? While starting the vehicle up or down from the incline, whenever brake is released, vehicle may tend to roll, which is not a desirable result. This may even lead to some unnecessary accidents, which may even become fatal. Hence, to avoid this rolling due to gravity, a technology was invented by Wagner Electric and manufactured by Bendix Brake Company under the trademark name of hill holder. This mechanism is used to prevent rolling of vehicle from slipping back. It helps to counter the force due to gravity on the vehicle due to the incline pulling the vehicle backwards. So in the image in the right side, we can see the effects on the vehicle on an incline caused with and without hack system, which is hill assist control. So actually, what is the problem? While starting the vehicle uphill, we need to release the brake pedal, which results in backward rolling due to gravitational force acting on the vehicle. This backward rolling of vehicle may result in loss of control of vehicle, and in heavy traffic situation, vehicle may even collide with the vehicle just behind it. Hence, to avoid this problem, a new technology is incorporated in mostly all modern vehicles. So in the image at right, we can see that inclined car is held in position due to hill hold assist system, and in the figure below it, we can see that as the brake is released to accelerate, due to the loss of brake power, the vehicle starts rolling back. So this may sometimes lead to fatal accidents if a vehicle is just behind the vehicle which has lost its braking power. So how do we solve it? To control the rolling of vehicle, an electronic system is used which holds the brake for a few seconds till the driver can shift to accelerator pedal, and as soon as the accelerator pedal is pressed, the vehicle achieves the start required and brakes are released. This system is active only when the vehicle is on incline, as on flat road this may result in unnecessary braking, which may even result in loss of power and may even lead to some kind of unnecessary damage. So how does a hill hold system work? So first step involves when driver presses the brake on the uphill or downhill condition to stop his car. As this is done, the pressure sensor in master cylinder measures the pressure required for the vehicle to hold its position. So next step involves this data is then transferred to the HSA module. Uh, so HSA means hill start assist. Now this module has the data for pressure required to hold the vehicle at its position. Next step involves the transfer of data to the hydraulic modular unit as soon as the brakes are released. This results in prolonged braking even after the brakes are released. As the accelerometer is pressed, the same HSA module detects the pressing of accelerator and disengages the brake. So how does the vehicle know whether the HSA has to be activated or deactivated? Actually, in older models, there would be a switch which would activate the HSA module. This was very tedious in application. Hence, to avoid this, a gyroscope or longitudinal acceleration sensors are used to detect inclination, and beyond a certain threshold the sensors are activated and this data is fed to HSA module, which then activates the braking system. LAS works on Hall effect principle. Generally this angle is predetermined as any angle above 3 degrees of inclination. This system works proportionally, which means the brakes are released proportionally instead of being released instantaneously. When coupled with transmission box, the entire system detects the extent and proportion at which the brakes must be released. So what are the advantages of hill hold assist? Hill hold assist provides higher clutch life, cost-effective solution, stress-free driving, prevents accident while starting the vehicle from the slopes. It is an advantage in heavily loaded vehicles. So what are a few disadvantages of hill hold assist? Holding the vehicle on foot brakes can lead to warping of discs, and maintenance cost of such a system is very high, and this is a relatively new technology, so a lot of car manufacturers don't bother to use such kind of technologies. Next up we have adaptive cruise control. So what was the need for an adaptive cruise control system was, as the accident rates in the years before the application of such a system resulted in some heavy crashes. This resulted in a dire requirement of an electronic technology to be implemented in existing automotive system. This concept of longitudinal vehicle control is known as cruise control. So what is cruise control? Cruise control is a system which automatically controls the speed of a motor vehicle, also known as speed control or auto cruise. The conventional cruise control has one mode of control, which is velocity control. Throttle position is adjusted to maintain a speed set by the driver. It improves the driver's and the passengers' comfort in steady traffic conditions. So, what are some setbacks of cruise control? The conventional cruise control is only capable of maintaining a set speed by accelerating or decelerating the vehicle. The driver always has to apply brake when approaching the target vehicle proceeding at a lower speed. In congested traffic conditions where speed varies widely, these systems are no longer effective. So now what is adaptive cruise control and how it is more advantageous over uh, traditional cruise control systems? So adaptive cruise control enhances the setbacks of traditional cruise control system by introducing new electronic components. Collision avoidance system helps in detecting the obstacle and tries to avoid it by strafing across it. Helps the driver to maintain the distance from the front vehicle by controlling the engine, throttle and brake. It also reduces the stress on the driver from frequent accelerations and decelerations. What is the working principle of adaptive cruise control? It works by detecting the distance and speed of the vehicles ahead by using LiDAR system or a radar system. The time taken by transmission and reception is the key of the distance measurement. The shift in the frequency of the reflected beam by Doppler effect is measured to know the speed. Depending on the speed, the brake and the throttle controls are done to keep the vehicle in safe position. What are the steps of working? First, we have to turn on the adaptive cruise control mode, set a predefined speed, then the sensors will detect the vehicle ahead, then the cruise control electronics detects the leading vehicle speed and decelerate to its speed. Then it starts maintaining the safe distance to avoid collision. So this is a block diagram configuration of an adaptive cruise control system, in which when we activate the adaptive cruise control system, it takes in the data from brakes, throttles, radar and vehicle speed sensors, and then feeds the appropriate data again to the brakes, main switch, accelerator and speed fixing switches and the speed indicators. This allows in completing a loop of data. This allows in completing a loop of data wherein the system becomes a closed loop system instead of an open loop system. So what are the components in active system? First one is radar, then comes the fusion sensors and LiDAR. So fusion sensors generally involve radar and LiDAR also, but we consider it as a separate sensor as cameras and other thermal sensors are also involved in it. Longitudinal controller receives the sensor data and processes it to generate the commands to actuators using control area network of the vehicle. Also, electronic vacuum actuators are used in such a system. Radar. It operates by radiating energy into free space and detecting echo signal reflected from the object. Currently used pulse Doppler radar uses the principle of Doppler effect. Current ACC systems are based on 77 GHz radar sensors. It detects object up to a distance of 120 meters and works in poor weather conditions also. Second one is LiDAR. It measures the distance by illuminating lasers and analyzing the reflected light. Cost is comparatively low. It provides good angular resolution. Weather conditions restrict its use to 30 to 40 meters range. Next one is fusion sensor. So millimeter wave radar linked to a stereotype camera with a 40-degree view angle makes up the fusion sensors. These two track the car from non-moving object. It was first used by Fujitsu Limited and Honda. So what are the advantages of ACC? Driver is relieved from careful acceleration, deceleration and braking in congested traffic. Accidents can be reduced. It is very useful for long driving. Can avoid unconsciously violating speed limits. Increased fuel efficiency. So what are the disadvantages of such a system? High cost, not for heavy traffic, encourages the driver to become careless, dangerous in slippery roads. A high market penetration is required if a society of intelligent vehicles is to be formed. The adaptive cruise control systems don't respond directly to traffic lights. So these are some references I used while creating the presentation. Thank you for your patience hearing. Thank you.